Hi everyone, we are Group 7 and we will be presenting on Project EduCat. Our client, Aspire Learning Center, is a tuition center. ALC focuses on a range of subjects for upper secondary students, and in 2020, it had 2 outlets and 89 students. ALC conducts its lesson physically. However, due to COVID-19, the center moved its operation online. For this project, our main source of contact is one of the co-founders. To dive deep into our business problem, the center currently faces 3 problems. Firstly, it wishes to adjust its pricing for online courses, but lacks proper forecasting tools to optimize its pricing strategy. Secondly, the center wants to expand its operation to a new outlet, but needs a more efficient way of evaluating potential spaces based on location and price. Thirdly, their current scheduling of classes is done manually and takes up a lot of their time. Hence, they would like a shadowing tool to reduce the time spent. Moving on to our deliverables, we have 3 main value propositions. Firstly, it is to perform a financial analysis that aims to determine the optimal pricing strategy, which performs a demand forecast, a profit and loss statement, as well as a pricing analysis. Secondly, to help our client evaluate the potential outlets, our model will allow the client to enter locations into an Excel interface and evaluate these locations based on cost and proximity to the MRT station and schools. Lastly, we will have a class scheduler which takes into account of the number of students, tutors, classrooms, as well as the students and tutors' timetable. This model creates an optimized class schedule, hence reducing man-hours spent and improve efficiency. Here is our model architecture. The first 2 components are demand forecast and pricing analysis that optimize the online tuition fees. Another feature is the profitability analysis that compares the potential profits generated from physical or online tuitions. Next, we have 2 key features that allow our client to compare potential locations for expansion and an automated scheduler that optimizes class assignment for each tutor. Lastly, it is the visual representation of student satisfaction survey results.
Firstly, for the demand forecast, we are projecting based on the trend analysis of historical data. By providing decision inputs like accounts in a class and number of classes taught by a tutor, we can derive the shown results. Similarly, the black box is a simple model with our consequence variables and performance measures feeding to other parts of the model. This model allows the client to project demand for planning and financial purposes. Our primary model is the profitability analysis. We looked at potential profits generated from having the tuition online or having physical tuition. The fees and costs will change depending on the mode of tuition as shown in the diagram. This will allow our client to make a financial decision on whether to continue having physical outlets or to move online fully. From the black box model, we can see that required decision inputs include operational data like number of accounts, which are unique students in a given class, and rental costs. Key result would be the net profit generated. This model determines the optimal pricing for the online-only tuition classes by maximizing profits earned. We conducted a survey of 50 participants regarding their willingness to pay for an online tuition offering. We performed a trade-off analysis by doing a scatter plot of the demand against the price to derive a best fit line, which we use to determine the price elasticity of demand PED slope. The net profits from each scenario were compared to derive the optimal online tuition fee. A sensitivity analysis was done to determine the sensitivity to the PED and online pricing. This is the black box diagram for the pricing analysis as described earlier. This model provides the client with an idea of the optimal tuition fee to charge should they wish to venture online fully. Next, to evaluate the optimal location for the next physical outlet, we will be looking at 2 primary factors, rental cost and location proximity. Rental cost is obtained from the rental area and rent amount, whereas location proximity looks at the nearest secondary schools and MRT stations. Our client can input up to 5 locations at one go, and the model will rank them in terms of cost effectiveness. This feature enables our client to easily determine the optimal location through quantitative and qualitative comparison.
Our 5th component is the class scheduler. So this component takes into account the planned class schedule and tutors' information such as status, subject, hourly rate, and maximum number of classes they can take to optimize the number of classes assigned to each tutor which would minimize the total cost of tutor salary. A user will interact with the form control button, which will run a solver VBA, which optimizes the assignment of classes to tutors. This is the black box model. So by reducing the total cost, it translates to lesser expenditure, improving the client's bottom line. This also allows our client to efficiently plan their class timetable and tutor allocations. The last component is our survey results. This sub-feature provides an easy-to-understand interpretation of the student satisfaction survey results. Our client has to update the raw data of student survey results whenever they conduct a survey. They will also be able to translate these results into summarized graphs and charts and print hard copy results with the simple click of a button. Moving on to our model limitations, the model may have used assumptions that were affected by COVID-19. Hence, to retain accuracy, the users would have to update the assumptions. The historical data was insufficient to perform backtesting for our demand forecast. The optimal location component does not account for a comprehensive list of costs and benefits and requires a degree of qualitative decision-making. While we acknowledge that there are limitations to the model, we believe that our model will help our client in the following ways. Forecasting profit and loss, optimizing the price for new online-only offering, evaluating the optimal location for expansion, reducing the time taken for monthly planning via class scheduler, and displaying survey results in an easy-to-read format. Even though we had occasional hiccups, we could recognize and apply relevant techniques and analysis taught in class to real-life scenarios. Through this project, we were also able to understand how vital Excel is in assisting business processes, and we helped reduce ALC staff workload.
So we'll now begin the demonstration of our model. The first component is the demand forecast. So the first step is to basically update the student survey results data sheet by pasting the result from a Google form into this sheet found here. So the template is actually the same as that found in the Google form, so user can just simply copy paste the data inside here. So going back to the demand forecast sheet, the next step is to then prepare the survey data that we just pasted in. To do that, we go to the survey result sheet and click on prepare survey data. And with that, we have prepared our survey data. So now we'll head back to our demand forecast sheet. And the next step will be then to input two variables. So firstly, the number of accounts per class, which basically dictates how many students will be found in a given class. And the next variable is the number of classes taught by a particular tutor. So once this two is done, simply click on reload and we'll have the results and key results as shown, total number of accounts, number of classes, as well as the number of tutors required to teach the number of classes that we have calculated. So that's all for the demand forecast. And these will all fit into profitability analysis, which is the next component. So the first step is to make sure that the linkage between this sheet and the demand forecast sheet is correct. So once that is done, the user will then have to update the key assumptions according to his own assumptions at that point of time. So then the next step will be to actually update the number of outlets and number of offices. So these two inputs basically is dependent on whether it's on a physical tuition mode of tuition or online mode of tuition. So both can be updated at the same time, but the relevant one will be selected based on the option as shown here. So once that's all done, simply click on reload and the financials will be auto-calculated out. So this is a pretty detailed financial statement, and thus I think our user will be able to find most of the needed key financial metrics here. So once that's done, we move on to our next component, the pricing analysis. So as you can see, there's a very familiar table here, key assumptions. So basically, we will see very similar key assumptions found here as per the profitability analysis table. So once again, just make sure that these assumptions are all up to date. And then the user have to make sure that the linkage between this sheet and a new public survey sheet is linked properly. So likewise, this sheet can simply be copy pasted from a Google form that we already have. So going back to the pricing analysis, the next step will be then to simply click on the reload button and the optimized online fee on a monthly basis will be auto-calculated. and shown here. And likewise, the profits along with it will be shown in this cell as well. So as you can see, it is the highest profits in all the scenarios that we have over here. So that's all for the pricing analysis. For the next two components, Ushan will be going through that. So I'll jump straight to the last one, which is the survey result. So survey result is pretty straightforward. It has the same first few steps as the demand forecast, where you just have to prepare the survey data. Once that's done, the graphs and charts here will be auto updated. And so the key feature of this sheet is actually that the user is able to simply print this report with a click of a button. So by clicking on print report, we are brought to this print preview page where the user can quickly inspect the sheet before actually printing it up. And so that's all for me.
Now onto our optimal location model. So on opening the workbook, there is a VBA in the background that disables the calculation in the sheet to prevent any unnecessary API calls that can incur costs for our client. To use this worksheet, users will input their ideal distance to nearby schools, potential rental locations, rent, and rental area. There are input validations to guide first-time users. So mode and API keys are parameters of the model and the Google Maps API. Mode has a drop-down validation of valid options that the API will accept, but we will assume no change from walking for our target audience students. So for our demo, we'll set this to 3 and we'll set Plaza 100. So once user has finalized their information, users can click on this button to enable calculation and trigger the model to recalculate by pressing F9. Let's go to the distance table and press F9. We can see that the distance is calculated for our new location we added. For our demo, we've limited it to 5 locations for the sake of speed. So we get the total cost, the number of schools and MRTs within the ideal distance, and the ratio, which is also visualized as a bar chart. So users will also be able to see the names of MRTs and schools with a spillover formula, and they are also linked to the Google Maps to view competitors in the area. So for the optimal location sheet, we are using 2 functions that are not supported by Mac, which are filter XML and web service. So our first function, web service, takes in the URL and returns us the response from the web service. In this formula, we use a concat function to build our URL with the correct parameters. Then we call the distance matrix API by Google to return us a response. Let me show you more about how it works. So here we have our values hard-coded in, and when I run the function, we get an XML response from the Google API. So this is the same thing as when we use this URL in the Chrome browser. So what we want here is the distance value, which we can obtain using the filter XML function to filter this value out. So in our filter XML function, we are filtering out the distance value. And when I run equals, we get 14533, which is the same as the distance returned to us by the API. For class scheduling, the user will plan for classes in the class timetable sheet that is linked here. And the total number of classes scheduled is calculated from the class timetable sheet, and the minimum classes for a full-time tutor is a parameter set at 2. So the decision variable for this optimization is the number of classes assigned, and the tutor's hourly rate and the table of constraints are based on business requirements. And these numbers are automatically fetched from the data sheets and will adjust accordingly when the data changes. So we have a VBA button here for the user to run the solver to minimize the total cost and get the optimal class to tutor assignment. Here, let us demo the run. And here we have the optimal number of classes assigned that is visualized as a pie chart.